In this section, we discuss how to relate exponential functions to real life. A couple of very basic examples, just to get you guys thinking about this for tomorrow. The first example is, let's say we take $1,000 and we put it into a bank account with 7% interest. Obviously not very realistic at this day and age. So the question would be, how much money would you have after 1 year? So after 1 year, 2 years, 3 years. And then basically write an equation for the amount of money after X years. And so the idea is just to kind of remember from algebra, you'd have $1,000 and you would multiply it by 1.07. Why? Because you have 100% and then 7% more. And that would give you the answer for 1 year. For 2 years, you would then take that answer and times that by another 1.07. And for 3, you do it again, take this answer, multiply by another 1.07. So in the end, you can see the pattern here, where this would be 1,000, 1.07. This would be 1,000, 1.07 squared. This would be 1,000 times 1.07 cubed. So the equation is 1,000 times 1.07 to the x, where this represents the initial and this represents the growth or decay factor. And this in here represents the percent per year change. I say per year, but obviously this could be per second, per whatever unit of time that you want it to be. So, same idea. I want to do one more. Let's say we take a car, and say you purchase a car at $16,000, and it depreciates, decreases in value. Each year. So the same idea, how much after 1 year, 2 years, 3 years, X years. And the key is, you have to make the connection that obviously the initial is 16,000, but the factor is now 0.95. It would be 100% minus the 5% that's being deducted. And that's why you get the 0.95. That's 100% minus 0.05, whereas up here, it's 100% plus 0.07 because you're gaining. So therefore, you can see the pattern. This would be this times 0.95, and this times 0.95 again. So the equation would be 16,000 times 0.95 to the x. So an exponential model looks like the following. We have y equals a times b to the x power, where a is the initial value, and this is the rate of growth or decay. If it is a growth model, then b is bigger than 1, which we saw in the first example, where it's 100% plus 7%. If it's a decay model, you would have b is less than 1, but greater than 0. And that wraps things up for this short mini lesson on exponential models. So for tonight, I would like you to do page 173, classroom exercises, numbers 3, 4, then written exercises, number 34 and 35, and then page 179, numbers 37. Thank you.